All right, students, as promised, I was going to go over this Brain Java that we didn't get a chance to do in class, but I handed it to you. And so taking a look at this first problem, it says sweep the arcs and angles, trace all triangles, find all possible arcs and angles. So for now, we're just going to trace the simple stuff. All of those are radii. The minute you spot a radius, you should mark them all equal right off the bat. There's a triangle there. Watch out for that. And if I identify that as the center of the circle, which I have with the dot, you want to trace, stretch, sweep the 180. And then what we have going here is if tangent to a radius, radius of tangent to a radius, right angle at the edge. So that unlocks the entire problem. You can see now here you have a right triangle right there, big right triangle. Using that right triangle, that's 90, that's 57. So I can go 90 minus 57. I'm going to borrow. And I get this little guy right here, 33. And then you just start asking yourself, well, what do I know? Hopefully you noticed that we have an isosceles triangle, 2 equal sides, 2 equal angles. So that's 33. Got another triangle right here, of course, right there. So add, take away from 180. That's going to be 180 minus 66. And I'm going to borrow from there. That's 4. And I get that is 1 and 14. And you just keep asking yourself, what else do I know? I know that adds up to 180. So I can do 180 minus 33. Yep, 147 right there. Right here, again, 180. And so that gets me 66. And keep asking yourself, what else do you know? And this is a pizza slice angle, measure of a central angle to its arc the same. Measure of a central angle to its arc the same. Let's see, anything else? We can obviously get the 180. Let's check for anything else. And that's how you find all your angles. So the keys to this problem, tangent to a radius, right angle at the edge. Also, watch out for isosceles triangles. This one, find all possible arcs and angles. So just kind of make note what we have so far. We've got a 70 there, got a 104 here, and our angle is 96. Couple observations. This is an inscribed angle, so it's an on. And we have an inscribed quad. Inscribed quads, opposite angles add up to 180. That's true of any inscribed quads. So I'm going to go ahead and do 180 minus 96 right off the bat. I get 84. And I can ask myself, what can I find? Well, if it's an inscribed angle, I'm going to stretch it out. Measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its planes. So if I have angle equals arc over 2, and my angle is 96, and I want the arc over 2, basically I do 96 times 2. You can see that there, 12 carry the 1, and I get 192. That green is 192. To find the yellow, we're just going to do 192 minus 70. You're like, do I want the yellow? I say find everything possible. So I'm going to minus 70. That's going to be 2. And that's 2. And so that's 122. Let's see what else I can find here. Let's see. I can go this way now. This angle grabs this arc. So I'm going to add 122 and 104, and I get 226. And then half of that, 226, is going to be 113. So I just found this angle right here. Once again, they add up to 180. So I take 180 minus 113. I get 67. And then the 67, I can drag it out from here to here, and that gets me double. All right, and that's going to be 134. And you take away 70 from 134. And that means this little guy here has to be 64. There, now we found all the minor arcs and we have found all the angles. So now we're going to go for the major arc, YZR. So you just have to make sure you go the correct order here and you just add stuff up. So Y, we're going to go through Z and end at R. So we're going like this. And whoa, lo and behold, we already have that one, right? It's going to be 104 plus 122. So that is 226 for the green. And this one right here, XRZ, start at X, go through R and Z. You can see that's 70 plus 122, so it's 192. And you are done. Watch out for these key things. Inscribed angles are half the arc, so you have the angle, you double to get the arc, and also opposite angles and inscribed quad add up to 180. It says a cyclist rides from Gilroy to Valley Christian. Just FYI, this was personally inspired by my coworker, Mr. Nauman. And both Mr. Nauman and his wife are long distance bike riders. So they actually bike ride from places like Gilroy to Valley Christian for fun. Yeah, I do not do that for fun. But they do. So on that note, let's see, we are going from Gilroy to Valley Christian High School. Gilroy to Valley Christian is approximately 50 kilometers. Okay, got it. The front tire of their bikes. Okay, front tire of the bike rotates. In that distance, it rotates 26,575 times. So that's how many times in general to get from one to the other, how many times the tire rotates. I'm asking ultimately, what is the radius of that tire? You're like, how can I get the radius here? Okay, radius, question mark. Okay, don't focus on what you don't have. So forget that I asked for the radius. Don't even worry about that right now. Always start with what you have, not with what you want. And let's look, we have the word rotate. Instantly, you should know the word rotate and circumference are equatable. When a tire rotates, it travels forward that length around, and that length around is the circumference. So the word rotate or rotations is the same as circumference. Just kind of keep that in the back of your brain. The rotation of a tire, length around, circumference, all of that is equivalent. So what that means is my tire is going to rotate 26,575 times. All right, in 1 kilometer. Now, watch it. I'm going to want that radius in cm. This current distance is in kilometers. So we got a conversion issue here. So these conversions you need to know. In a kilometer, there are 50 meters. So 50 kilometers. And for every kilometer, there is 1,000 meters. And for every meter, there is 100 centimeters. So I'm going to get the distance from Gilroy to Valley Christian in centimeters by doing 50 times 1,000 times 100. Since this is in metrics, all you have to do is count the zeros. Yes, you can use a calculator, but I'm going to show you how to do this just counting zeros. 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. Put the 5 there. So there are 5 million centimeters from Gilroy to Valley Christian. For those of you who are a little paranoid about that conversion, I can show you on a calculator. We're going to go 50 kilometers times 1,000 meters times 100 centimeters per meter. And there it is, 5 million. Okay. So our tire rotates 5 for 5 million centimeters. It must rotate 26,575 times of rotation. So I want to figure out what a single rotation is. Single rotation. So I simply divide my distance, 5 million, by the number of rotations. So 5 million divided by 26,575. 5 million divided by 26,575. Okay, that gives me my per rotation centimeter distance, 188.15. So in a single rotation, I travel 188.15 centimeters. Now, always ask yourself, what did I find? I found when that wheel rotates, it goes forward 188.15 cm when it rotates. And remember, rotation and circumference are equivalent. So if my rotation equals 188.15 cm, my circumference equals 188.15 cm. And my circumference equals d pi. D pi equals 188.15 cm. Last step, or second to last step, I can divide by pi, and I guess you're just asking yourself, what can I find here? So I take my diameter and I divide by the pi key, or 3.14, I get 59.88. Diameter is 59.88 cm. And the ultimate question was not diameter. The ultimate question was radius, which is half of the diameter. So I divide that by 2. And I get approximately 29.9 cm for my radius. Okay, last problem. It says the length of the radius below is 10 centimeters. I'm going to color code this. And you're like, radius, where is there a radius? Well, there's a radius here. So that's 10 cm. Oop, and there's a radius here as well. And so that's also 10 cm. And the length of the chord is 16. Chord is this whole thing. And we learned earlier, if perpendicular, then bisect. So I know immediately I have an 8 and 8 cm. And it says find all possible. You're like, there's nothing there. Okay. I'll give you a little hint in a circle. If you're like, I don't know what else I can find, it seems like everything's labeled. You ask yourself, is there a right triangle? And if there's not a right triangle, can you make one? Because the right triangle is the key to every single problem, just about. So what you need to realize, you could always draw in or move a radius. So a radius goes from center to edge, which means I can do this. Oh, looky there. I now have a right triangle, which just unlocks everything, friends. So right here, have two sides, need third side. Thag, I can do leg squared plus my unknown leg squared equals 10 squared. And you just do your math here. So x equals 6 here. That little piece right there is 6. And then you ask yourself, but wait, there's more. So if this whole thing is 10, if you see that little dot there, and this is 6, 10, 6, that means right here is going to be 4. You kind of look, any other segments we can manage? Well, I mean, I could go this way if I wanted to, I could. So that's 10 cm. And you're like, okay, no more segments. But Miss Way says, oh, angles, arcs. And keep in mind, you have a right triangle here. I'm going to shade it in. Let me pull out that right triangle for you. That's 10. That's 6. That's 8 cm, right angle, cm. And to find an angle, okay, theta, we're going to use inverse SOHCAHTOA. We use SOHCAHTOA to find sides and inverse SOHCAHTOA to find angles. So if that's my theta, I'm going to label my theta, I'm going to put right here. And there's a reason why I put it there, because it's a central angle. And measure of a central angle to its arc the same. So that's why I'm going for the theta inside there. This is opposite. This is the adjacent. This is the hypo. Notice I have my opposite. I have my adjacent. I have my hypo. I could use any one of the inverse sine, inverse cosine, inverse tangent. Just for giggles, I'm going to go inverse tan. So inverse tan, my opposite is 8. My adjacent is 6. Pull up my calculator. Most of your calculators, you do shift tan first. My calculator goes backwards, so I'm going to go 8 divided by 6. Second function, tangent, and I get 53 degrees there. Just right here. And that one right there, you take it away from 90, and I'm going to get 37. Measure of a central angle to its arc the same. This is the same triangle, so this is 53. This is 37. And if you go like this, that's 180. I've got 106 there. From here to here, 106. And we take that 106. That means from here to here is going to be 74. And then, of course, we have 180 going this way. And you check, make sure you got all your angles. Got your 90s there. And oops, I forgot one. Central angle right there, 74. And we are good to go.